going to talk about fire blocking. Now what we're doing here with the insulation wrapped around the foundation, this is, in my opinion, the best way to try to achieve moisture and vapor proofing. But the problem is there isn't a particular code around this, but there are codes around fire blocking. And in trying to do both, it becomes a bit tricky. The issue is that fire blocking is meant to delay or prevent fire from moving from one cavity or enclosed wall space into another. When we have the foam on the walls here, this is not a fire-rated material. This will melt and it will actually give off some fumes, and so there's some concerns about this being in an area that is meant to be fire blocked. There are ways to work around this, but it can be a little bit more complex, and it might depend on your local areas and your local codes in terms of what's going to be accepted, or your local inspectors. There are various ways that you can achieve both the moisture and vapor proofing, but also meet the fire blocking codes. I'll talk a little bit about this here and some of the options. The reason for fire blocking is to prevent a fire that may start or ignite in one enclosed area of a wall from moving into another. For example, if we didn't have this here and a fire started inside this wall cavity behind our closed wallboard, that those hot gases and flame are not going to be able to migrate up behind this header here and then in through this cavity, for example, and up along the floor or up into the next wall in the second floor above us. So that's the whole purpose for the fire blocking. Letter of the law, so to speak, according to the code, it requires that you fire block an enclosed space at the top plate and also every 8 feet of enclosed wall space. So if you had just drywall and just open cavity studs, fire blocking code allows you to just block off all the way across the top with approved fire blocking materials, and then at every 8 feet along the wall. So here I've set up just a few pieces to give an example of the types of materials that you can use for fire blocking. According to IBC, you can use 2-inch nominal lumber, so a single thickness of 2-inch nominal lumber. You can use 2 thicknesses of 1-inch nominal lumber with the joints overlapped. So in this case we have one thickness here and another thickness backing it, and it needs to be continuous all the way along the entire fire blocking line. You can also use a single thickness of 23/32 engineered lumber. So in this case we have an example of plywood. So you can use a single thickness of this all the way along, but then with the joints backed by another piece of the same thickness. You need to use the backing all the way along the entire fire blocking panel, but anywhere you have a joint, you have to have it lapped and backed by another thickness. And the same thing with particle board. You can use 3/4 inch, a single thickness of 3/4 inch particle board all the way along, with again backing by another piece of the same thickness behind the joints. Additionally, besides the wood materials, the IBC allows you to use gypsum board, cement fiber board, or bats or blankets of mineral wool, glass fiber, or other approved materials installed so that they would be securely retained in place to be used as an acceptable fire block. They cannot be loose fill so that they would fall in case of a fire or any kind of deterioration, but something that would be held in place. The material that I'm using for my fire blocking is this rock wool Safe and Sound. It's made by a company called Roxol, but it is a rock wool material. You can see here that it is fire resistant properties as well as an acoustic attenuation properties or sound absorption, and it also is water repellent and water resistant. So for our basement project here, this has all 3 features that I really want in the basement. Water resistance in case there ever was water impregnation or flooding or any kind of incident like that. This is going to be mold resistant in that as well because there isn't organic material. This is made from rock. It also is sound absorbing, so that's going to really help us with any kind of multimedia areas or blocking sound from going from one level or one room of the basement to another. And of course our fire rating. This material actually is rated to be able to sustain up to 1800 degrees exposure. You can look up more information on the company's website. You can find a lot of videos
even video where you can see that a direct flame applied to the material would not cause it to burn.
So these are actually 15.5 inches roughly in width, and therefore they're a little bit wider than your typical 16 on center spacing in between your walls, which is 14.5 inches. And so when you press this into the wall, or I should say you fit it into the wall, it actually compacts a little bit so that the sides will compact in and press themselves up against the studs so that they're self-retaining. So here you see an example where the rock will bat is self-retaining. It's just fit inside of that space, and you can tuck it in and compress it, and therefore it is self-retained within the studs.
So theoretically, or in reality, you can have completely open wall spaces up to the top and across for 8 feet. What that means is, if you think about how a fire might start inside a wall, where are sources of ignition? Sources of ignition are primarily going to be your electrical boxes or anything similar, outlet switches or anything like that where you have an electrical connection. The idea is, let's say if there's nothing here in this open cavity and a fire starts in this box, that fire can propagate throughout this entire wall all the way up to the top and across 8 feet, and you can have a fully open area where there is open flame or hot gas in that area. The purpose of fire blocking is try to keep those hot gases and flames contained in that up to ceiling and 8-foot area. I'm going to show a couple ways that we're going to be able to achieve fire blocking to meet the codes. And in this case, what you see here, we've got our foam wrapped up against the wall, all the way up around the rim joists and so on. And then I'm going to show you here in this diagram how we can work around that. If you try to address the intent of fire blocking, it's to control the spread of the hot gas and flame. One thing that I'm doing here can be approved in many communities. It depends on your local code and inspectors. But the idea here is that if we block and suffocate any potential source of ignition around the box, then that fire is not, if fire did occur inside this box, it's not going to be able to propagate outside of the area. So as you see over here, behind the box, I've got it fully encapsulated with a fire blocking material. I've then filled in all the way around the block, or the box, with a fire blocking material. And of course on this side we have our 2-inch nominal lumber, which is again is suitable fire blocking material. So therefore any fire which starts in this box, once the drywall is over the top of this, if that fire starts in here, there's no way for it to pull enough oxygen to keep a fire going, and therefore we're suffocating the point of ignition. So how I'm doing that, as you can see, I'm making sure that I'm using suitable fire blocking material, filling in all of the cavity and gap behind the box. I'm making sure that the box is up against a 2-inch nominal lumber, and then I'm going to fill in all the way around it by using my fire blocking material. So here I've got an example. Cut a sheet, fit it in there. I'm going to find out roughly where my opening is here that I need for the box. Just using a bread knife. This material cuts really easy with a bread knife. And then I'm going to fill in the rest of the cavity around that block, around that box, I should say, with our fire blocking. So now, this box, if there was ever a fire in this box, there's nowhere for that flame or hot gas to go behind the box, and there's nowhere for it to go around the box, especially once we have our dry roll over the top. So now I've talked about how I fire blocked around all my boxes. What I can also do, if that isn't considered sufficient by your inspector, the next way you could go is by also fire blocking on every 8 feet all the way up and all the way across. You can see as I'm starting it here, I've got my fire blocking that's going to go in behind the studs, I've got my fire blocking that then is in between the studs. So at the end of the day, this entire cavity will be completely filled, no space for air or oxygen, and any hot gas that might escape into this area is going to have a hard time working its way through here, even if it has to go through the entire layer and cross section of the foam all the way across. Same thing on the top end. You can block off 18 inches. In many cases, 18 inches is considered suitable fire blocking space if you used other kinds of insulation materials or fire blocking materials. So here we're going to use 18 inches of our rock wool insulation, tuck that up behind and make sure it's behind all the studs, and then of course in front of it again, and block off that area. And of course we have our fire blocking going across the top plate. So at the end of the day, if blocking around the ignition points themselves is not considered enough by your code inspector, then you can go to this next level, and then that's making sure that you're blocking off there and you're blocking off your 8-foot width cavity and at your top plates. Now if we're going to do that, we're going to need to be able to fill in both behind the studs here, because there's air cavity here, and also in between the studs. And you can see how I'm doing that here. Here's my fire blocking material behind the studs, and here's my fire blocking material in between the studs. Also, as we wrap up into the rim joist and in between the floor joists, you want to make sure that that fire blocking material is going up behind the top plate, and you have fire blocking material coming over the top. So at the end of the day, your fire blocking is creating a crossover barrier just like this, as I showed in the diagram. If that ultimately was not enough and the inspector wanted more, then ultimately what you can do is fire block your entire cavity, as you see here. So now what we've done is filled in the entire cavity around the electrical boxes and in between all of the wall spaces, and now the cavity is completely full. So even if we have foam on the other side, this entire cavity has no air or oxygen to allow ignition or the continuation of a burn to go through. And this is the maximum you're going to be able to do to achieve both the exterior foam vapor barrier layer and then also the fire blocking you need to achieve code.
When fire blocking, you also need to deal with spaces that are open between ceilings or floor openings. So you need to apply a suitable fire blocking material anywhere where there are openings around things such as vents, pipes, ducts, chimneys, fireplaces, or anywhere else between ceiling and floor levels where you've got an open space. This prevents the movement of hot gases and flame to move through an opening from one area of the construction to another. So here you can see I've used the fire blocking foam to seal off any of the open spaces between levels.
I'm also using a spray foam material. This one is by a company called Great Stuff, and it is specifically a fire blocking material. This is rated for fire blocking purposes, as opposed to any other spray foam that's going to melt or deteriorate very quickly in a hot gas or a fire situation. This specific foam is made for fire blocking purposes.
Fire blocking is also required underneath stairways, between the stair stringers and at the top and bottom of each run. So before enclosing this space, we need to properly fire block this again with appropriate fire blocking materials.